Can you hear me? Yes. Cool. Well, good afternoon. I hope everyone enjoyed their lunch. My name is Justin Davies. I'm a PM on the AKS team. I look after more of the operator side of things, so basically how to make operators' lives much easier. The clicker isn't working, so I'm going to be walking backwards and forwards to be able to do this. Project. Okay. Thank you. So the first question we have is kind of why manage Kubernetes, and also why Kubernetes. The thing that I think we forget sometimes, even within the AKS product group, is really the reason why people adopt Kubernetes in the first place. And so one of the foundational things is kind of it works on my laptop, and what I run on my laptop is what I want to be able to run into production. The triple P issue, which is push to production problem. I used to work in the financial services industry, and we had to be able to push into production guaranteed on a Sunday evening, ready for the markets to open on a Monday. Invariably, 80% of the problems that we had when we were pushing into production was missing dependencies, configuration changes, configuration drift as well. And so Kubernetes fixes those problems for you. The whole idea about resource health and health monitoring and being able to make sure that your pods are still running and migrated over to running nodes means that you should reduce issues with pages and people being woken up at 2 o'clock in the morning, because Kubernetes should take care of it for you. And also then the key, the crux of this, is that we're trying to deliver value. We're trying to deliver software quicker, easier, and much quicker into production to be able to actually get that value. So I was just kind of jotting these down the other day, but the problem of the operator, and the problem of the operator when we're talking about a managed Kubernetes offering. And the main one is how many captains are on the ship? Who is actually operating it? Is it the AKS team, or is it you as operators? And so we have to try and figure out what that balance is in terms of what we do to be able to make your life easier as an operator, and for us to be able to maintain the service and the control over that. So some questions you may ask yourself: what's my infrastructure spend? What do we need to be able to run this? So what are my dependencies, the interdependencies between my different components? Why do I even need to worry about this? Could also be an argument that you have as well. It's like, I want to run my workloads. I don't want to have to worry about running a Kubernetes cluster. And so as a managed service, what we try and do is give you the option of being able to actually have this stuff taken care of for you. And I'm basically going to run through the story in terms of what we have from an ops perspective to make your life easier, if you so choose to be able to use those features. So when we think about the ops tool bag that we have in AKS or for AKS, I can't read that, I'm going to have to stand over here. The ops tool bag that we have, so one of the really kind of important things, both from component updates as well as security updates, is the node image itself. So what actually underpins the AKS nodes within your cluster. We, as AKS, from the Linux side at least, we basically roll out, where is that coming from? Let me stand here. We basically roll out an update to the node image once a week, and you can consume that as well. That has bug fixes from Ubuntu or from Mariner, whichever Linux operating system you choose, as well as component updates from us. And component updates could be a bump of an add-on, for example. A component update could be a brand new feature that we've released, or a feature going from preview to GA, is all self-contained within the node image. It's your responsibility as the person that owns that Kubernetes cluster as to when you consume that node image and when you want to be able to roll that out. Things which are quite tightly coupled together, node image updates as well as maintenance windows, allows you to be able to do a deployment of a node image, and I'll show this in a second in a demo, as well as things like update search. How many of my nodes do I update at the same time? How many nodes do I take down, and what effect is it going to have on the service level of my applications? And the last two ones on the component and host updates, N-3 support. This is really important to be able to understand. AKS and Microsoft will support you N-3. So 125, 124, 123. If you're on 122, we will help you, but the first thing that we'll say to you is please upgrade to the latest version. And so it's really important that if you want to have the latest versions and you want to be kind of in support and be supported by us, you need to be on a supported Kubernetes version. I put release notes in bold there because these are also really important. Every time that we do a VHD update or a node image update made available to you, our release notes on GitHub will tell you exactly what is in there, what packages are in there, what bug fixes, what component updates, whether something's gone from preview to GA. We also use that facility to be able to inform you of things that are upcoming and potential breaking changes that may be happening both in Kubernetes or something that we've changed as well. So it's really important to keep up to date with those. From an availability perspective, we have a couple of really nice features, which I'll also demo as well. Node auto drain, which is basically if the underlying VM running on Azure receives a scheduled, what we call a scheduled event, so a preempt, for example, which is if you're using a spot instance, we will get prior warning from the underlying Azure fabric to basically say, hey, I'm going to take this VM away. Node auto drain will basically say, okay, I understand this is happening very soon, and it will cordon and drain the workloads. What would have happened before node auto drain is that your node would have just gone away, and you would have to wait for the Kubernetes control plane and the scheduler to reschedule that workload, which adds extra time from an availability perspective. So we're shortening that down. Some things that you need to be able to do to be able to make sure, and Patrick talked about this as well, is the contract that you have with us. For us to be able to provide you with a service that actually is available and resilient to be able to run your applications, there are some things that you need to do as well. So health and readiness probes, for example. Don't run applications on your system node pool. All of the stuff that Patrick had talked about previously, these are really important things to make sure that your applications run and we can manage the infrastructure for you. From a monitoring and telemetry point of view, we now have managed Grafana and managed Prometheus, and I'll show the managed Grafana side of things in a second, where basically you can just instantiate that. The Azure team will run that for you, and it will allow you to be able to plug into Azure resources, not just AKS, but other resources like VNets, VMs, and get all of the telemetry that you would get from log analytics, but displayed in Grafana, which is really, really, really neat. So, updates. I can't stress enough how important this is for customers to maintain their nodes. A lot of the support requests that we get from customers is because they haven't updated or there's a bug which hasn't been fixed. And so we patch your nodes for vulnerabilities. That happens every 24 hours. We'll go and check and install those for you. But we release a VHD every week. Look for our GitHub updates to be able to see whether you want to consume that. But the node image incorporates component updates and bug fixes as well. And I've already talked about as well, N-3 support. It's really, really important to make sure that you're supported so we can look after you. So, in terms of node image and maintenance, node image updates specifically, we're talking about the node image here. We have the idea of update channels. And so you can basically say to us, I want you to be able to upgrade my cluster, and we have none, which is completely disabled, which is default. Patch, which basically means that your Kubernetes version is at the latest patch release for the minor release that you're running. So 124.3, 124.4 comes out, we will upgrade your Kubernetes across the cluster for you automatically. The third one is stable, which is a little bit complicated, but if the latest release is 124, which is currently GA, stable is the latest patch release of 123. So when we say stable, we mean, okay, there is a GA version of Kubernetes, but the one before that is classed as stable, has been out in the wild longer, and therefore we'll keep you updated on the N-1. Rapid is go fast mode, which is basically be on the bleeding edge constantly, and we will make sure that we update GA releases of Kubernetes and patch releases for you. For node images, we also have the ability to be able to do those deployments for you. So we release a VHD image for you on well, it will be different days of the week, but every week we will release that. You can specify that you want your clusters to be automatically upgraded. And you can specify this at a cluster level. So you can have your pre-production environment saying, yes, update me every single week. If something breaks, then we know that it's an issue. If we're happy with it, then we can go and do that deployment in production manually, for example. You can also control this as well with maintenance windows. So I'll just show you a quick demo of this and what that looks like. Hopefully this works. Okay, so here we're basically setting the max surge. So we're basically saying we're going to take out or update 30% of the nodes within the node pool. And here we're basically going, okay, we're going to do the upgrade of my node pool and node image update only. So it's going to take the latest version of the node image and it will blap that across my cluster for me. Takes a little bit of time. I have cut this down a little bit. Okay, so that's done. Now I'm setting the node auto update channel to node image. So that's the first step in terms of full automation. And the next thing that I want to do is a new feature we have, which is using a maintenance window controlled by Azure Maintenance to be able to specify an MRP configuration for every weekday to be able to do that deployment. So we're saying at 8 p.m., I think it was, we will do a node image update once it's available. You can be super granular in terms of this as well. You could say only do it on a Friday, for example, only do it on a 1 o'clock on a Sunday, and you can apply these at different clusters. So you could say, do my pre-production clusters on any day of the week, but my production clusters will only happen at 1 a.m. on a Sunday. That keeps you up to date. Make sure that you have your components updated and your security patches deployed as well. So auto drain, as I said, it will basically look, it will alert you within the node events in terms of freeze, reboot, redeploy, preempt, and terminate events. These are basically events that happen on the underlying virtual machine. Nothing to do with AKS, everything to do with the Azure infrastructure. And we will listen to these. And so we take action when there's a redeploy, a preempt, or terminate events. That's basically a redeployment of your virtual machine from one physical host to another host because there's underlying maintenance. And so we can cordon and drain that for you, and that happens automatically. Preempt, I talked about, which is spot instances, and then terminate events, which is basically Azure is saying that your VM is going to be shut down for one reason or another. And this happens automatically. And we're going to be building in more logic and more things into this in the future to be able to help customers with different types of workloads and different triggers that we'll need to be able to cordon and drain those workloads for you. Node auto repair, much like auto drain, is one of those you don't need to do anything features, but is really interesting as well in terms of what it does. If we see that your node has gone into a not ready state, we will basically try and automatically reconcile that for you. So that will be either through a reboot, so turn it off, turn it on again, see if that fixes it. If that doesn't work, we'll then re-image the virtual machine that you have. And finally, if that doesn't work, we will then redeploy a virtual machine with a new node image and basically try and get your workloads back up and running as quickly as possible. Release tracker, so talked about the release notes, but basically with release tracker, you can see where a VHD update is being rolled out. When we do deployments for our customers, for both our underlying service as well as VHD updates, we deploy that quite slowly over around about a 2-week period from once the VHD is available, we deploy it into our canary regions, our test regions, then we deploy it out globally. You can actually see where all of those are in the world, and if you're looking for a specific feature, you will know when it hits a specific region. So here's the release tracker. It basically gives you a list of all of the versions that we have, as well as then the regions that they're going out of. You can also then scroll down, click on the link, and see what the change log is for that release, so you know exactly what you're getting. Okay, so that's kind of things that we do to be able to make your lives easier as an operator and things to be able to maintain your cluster. Now let's talk about scale. So one of the other jobs of a Kubernetes operator is to really think about, unfortunately, is to think about how do I scale? I say unfortunately because whilst your application developers are developing software, they're thinking about delivering that value. You're thinking about hosting that value and making sure that it stays up and running for you. And so we need to think about what are your scale levers? How do you actually scale your infrastructure? And we kind of break these down into a couple of different things, really. One, networking. How do I scale my networking? Because it's the cloud, it's sitting on the internet. You do have to think about networking. You do have to think about traffic flows as well. Second element of this, then, is thinking about my infrastructure. How am I scaling my infrastructure? How am I actually moving my nodes up and down? How am I actually creating new SKUs or new VM types to be able to run my infrastructure? And then thirdly, and this is kind of the sweet intersection between Kubernetes and AKS, you then need to start thinking about how do I scale my applications? What are the triggers and the levers that help me to be able to scale those applications? And so we'll break that down, and storage as well, which I'll go do a bit more of a deep dive at the end. And so we kind of break this down really in terms of what are those options and what you need to consider and think about while you're doing that. So first one is the control plane. If you're running in production, we highly, highly recommend, I can't stress that enough actually, we really recommend that you run the SLA control plane. As well as having a kind of a cost associated with it, which means that we can give you that money back if the availability of that control plane goes, it actually means that you get more resources on the control plane. And it means that we actually scale the control plane for you. Now, that's great. You may just think, well, okay, I don't want to spend the $72 a month, but do take that into consideration in terms of you enter a support ticket and you say, my API server is overloaded because you've got 2,000 watch processors going on. We are going to say, yeah, you probably need to upgrade to, you either need to stop doing the massive amount of watch events, or you need to upgrade to be able to use the SLA control plane itself. So that's one piece of guidance that we have, first of all, when we're thinking about scale. So let's have a look at application scaling. So traditional Kubernetes, you obviously have your pods scale horizontally. Your pods, when they scale horizontally, need to sit on infrastructure, which I'll come back to in a second, but we have horizontal pod autoscaler, which is there. You get it out of the box. Scaling with KDA. KDA is now an add-on. KDA, which I'll be demoing, basically allows you to be able to take application metrics or any type of metrics that you want, whether it's kind of queue depth on a service bus queue, for example, to basically inform when your pod should be scaled or when your deployment should be scaled up. And then scaling vertically, which I'll also demo, using vertical pod autoscaler, that's also an add-on now as well. And again, this is one of those kind of interesting things as a managed service and why we help you in terms of the operator side of things. The whole idea behind the add-on model is that you don't have to worry about that infrastructure. You don't have to worry about when a new version of KDA comes out or VPA comes out. We manage that for you. If you have it enabled within your cluster, we will make sure that the CRDs are deployed, we'll make sure that they are working, and we'll make sure that when a component bump comes out, as part of the VHD update, it will be deployed and managed for you. So for you, you want these extra tools to be able to do your job. We will take care of basically managing and maintaining that for you. You have to just deal with the configuration. So when we look at the different kind of VM types and the compute types that we have Gen 2 VMs, both supporting Linux and Windows, and then we have different VM types for different types of workloads. So you may see different things about the memory to CPU ratio, for example, will be different on an F series compared to a D series. That's for memory-intensive workloads. GPU, InfiniBand, all of these things that basically they are VMs which are specifically designed for specific types of workloads. And as a VM becomes available on Azure, invariably it will be available on AKS as a fast follower as well. So as we innovate across Azure, you get that by default as it goes into the AKS backplane. And we also, as George said as well, GA'd ARM infrastructure and ARM node pools as well. I was going to do a demo, but then I just thought it was a bit boring, but I really liked it because I'm geeky. I was going to have basically an AKS cluster with an ARM node pool, Windows Server 2022 node pool, 2019 node pool, a Mariner node pool, an Ubuntu 18 and an Ubuntu 22. Then I realized that I didn't have enough quota, so I didn't bother doing it. But it would be, you can basically have a single cluster which has all of these types of node pools in there for you to be able to run the workloads you want on the types of VMs that you want as well. So when we look at node scaling options, the way that you want to do this is really down to you and how you run your clusters. The most boring way is the one on the far right, which is basically scaling your node pool manually. You can go to the portal, or you can use the CLI, and you can say, great, my node pool has been increased to 100 nodes. That's not much fun, though. The whole idea behind a managed service is that you don't want to be paged at 2 o'clock in the morning, so why don't you turn on Cluster Autoscaler? And Cluster Autoscaler is based on the fact that you have pending pods. So we have a number of pods which can't be scheduled, as long as you've got your limits and your requests set correctly. The scheduler will just not schedule those. Cluster Autoscaler will go, pending pods. I need to scale up my node pool to be able to deploy this workload. And when those pods go away, it will then scale them back down. Does your job for you. Wonderful. Third element of this as well, especially if you kind of have kind of a low watermark and a high watermark in terms of where your cluster or your node pools are going to scale to, if you want to be able to make sure that they scale quicker than basically doing a full provision of the virtual machine, you can use scale down mode. Scale down mode deallocate will basically do a live kind of push of the maximum amount of nodes that you want. So let's say hypothetically it's 100, and it will basically deploy all 100 of them. And it will then deallocate, which basically means it will turn off the compute resources and you get charged for the storage only. What that means is that when you scale back up, you don't have to wait. The only thing that you have to wait for is the compute resource from Azure, because your operating system has already been deployed and is ready to be able to go. I'd get this turned on in the larger demo that I do as well, to be able to kind of bring all of these things together, just to see how quickly these things scale up. And then finally, you have the option of bursting using Azure Container Instances with virtual nodes. Virtual nodes and kind of ACI integration has been around for quite a while. You'll be pleased to hear that we are kind of putting more investment into that now and are actually closing some of the gaps that we have around virtual kubelet and ACI. So we now support Azure Files v2. Init containers are now supported in virtual kubelets and ACI, as well as being able to actually pull images via a managed identity. We are continuing to be able to close the gaps, and you'll see that those coming out in the release notes, as I talked about as well, in terms of the availability of these features. So a couple of best practices to keep in mind. I won't labor on this too much because Patrick went through most of them. Use cluster autoscaler and HPA as much as you can, because it really just does the scaling for you. And the thing which is going to inform when you scale is going to be your workloads. And so let your workloads do it. Kubernetes is about your workloads, it's about your applications running. Kubernetes is an abstraction away from the infrastructure. So let Kubernetes take care of that for you, because it will save you a huge amount of time. Set maximum pods per node based on your, on kind of, on how many pods you actually want to be able to deploy in there as well. That will help you in terms of having a level of control over that. But also then start thinking about pod disruption budgets, like Patrick said. Make sure that your taints and tolerations are all set up, and really allows, again, the definition of how you scale and how you place an application based on your workload definition. So networking. In terms of north-south networking, we have app gateway, standard load balancer, which is the standard which will be deployed for you as you deploy an AKS cluster. And we also have managed NAT as well. Managed NAT is all about being able to fix the problem that you have with source NAT exhaustion. Managed NAT is there. You can basically spin up a cluster, and we will manage that NAT gateway for you. Or you can bring your own NAT gateway and attach it to an existing VNet, and your egress traffic will go out of that. If you ever have SNAT issues, the first thing that support's going to say to you is, have you heard of managed NAT? Please deploy it, because it will fix these issues for you. So things to keep in mind in terms of networking. So Azure CNI gives you the bells and whistles. It's basically Azure CNI. The clue's in the name in terms of what it provides to you. All of the bells and whistles that you would get from networking in Azure are all built in here. So we would always recommend that you go there. The first argument that customers come back to us with is, well, IP exhaustion. How are you going to be able to fix that for you? Just bear with me until the next slide. Use managed NAT if you're going to have a lot of egress flows, because it will save your life. And then plan your IP addresses as well. Cloud is the same as on-premise when it comes to these types of things. You know, size of your VMs you have to think about, your IP address space you need to think about. We try and make this a lot easier for you in terms of lowering the IP pain that you have, especially around things where customers are concerned with using Azure CNI traditionally would basically mean that it would currently, if you went for the default, that every node that you have within your node pool, if you set max pods to 30, each node would take 31 IP addresses as soon as it's instantiated. And that's a complete nightmare, and we hear you. So we came up with two features. One is dynamic IP assignment, which basically means that we will only pull an IP address when the pod starts running on that node. So if you have a node with no workloads, it'll pull one IP address. First workload, 2 IP addresses, and so on and so forth. So that dramatically fixes the problem, right? But the challenge is that, yeah, but what if I have to scale my node pool up to 500 nodes, and I'm going to be running 6,000 pods on there? Well, do the math, that's an awful lot of IP addresses which are going to be pulled dynamically from you. And so we came up with a third option for you, which is currently in preview, which is Azure CNI. It's basically an overlay network on top of the VNet itself. And so what happens is that if you have 100 nodes in your node pool, they will use 100 IP addresses from your VNet. Your pods, on the other hand, though, will be on an overlay network within those nodes. So it doesn't matter how much you scale, apart from the kind of infrastructure that you have, we will basically take care of making sure that we overlay that for you. And so you still have to think about the IP addresses. You still have to think about, well, what's the maximum hardware scale I'm going to go for? What IP address ranges do I need to be able to use? So consider that, and that will really help you. Right, so put this demo together. Can you see that? Yes. To basically bring all of these things together. So this is an AKS cluster, which I created, or I'm creating, with deallocate. So scale down mode is deallocate, as well as having overlay CNI. Okay? And so what I'm doing here is basically creating that. And I've chopped this down a bit so that you're not going to be bored by it. It's basically the set deallocate mode on a node pool that I have, cluster name. I'm also setting up min count, max count for the number of nodes that I want to be able to scale up or down from. And we've enabled cluster autoscaler on this as well. So that's going to be deployed. What I'm doing with this workload is that it's using CADA to be able to do application scaling. There is essentially an analytics workload, I guess you could call it, which basically listens to messages from a service bus queue. And so we push load onto the service bus queue, and we basically consume it and do some analysis on there and actually pull data from Azure Blob Storage as well. So for CADA, we basically set up the definition for the scaled object, and it's actually taking the queue parameters, the authentication parameters from my pod spec itself, and it will basically listen to that queue. And so it will basically say, okay, the queue depth is more than 10, I now need to start scaling my workloads up. So we're doing the deployment both of my deployment itself, which replicas is set to 0, because I'm letting CADA take care of all of this for me. Do the deployment. This is just a very quick hack to be able to push messages in. And this is managed Grafana. So what I'm doing here now is just checking. Okay, there's no pods, nothing's running. Check my nodes. Okay, they're all in not ready state. They're all deallocated, apart from one. I'm not sure why that was there. And what I'm going to do now is just basically push some load onto the server. So that's going to push around about 2,000 messages onto the server, and that's going to wake CADA up now. What CADA is going to say, okay, I now need to do something. I now need to basically scale my application up. And what's going to happen is CADA is going to go, okay, great, horizontal pod autoscaler, do your work, scale my pods up. What's going to happen is that it's going to say, oh, I can't schedule them anywhere because there's no infrastructure. So then cluster autoscaler is going to kick in and will automatically scale my nodes up to be able to accommodate those workloads. So this is the managed Grafana that we have running here now. So that's just running in Azure. I literally a couple of drop downs, and I basically plugged that into my AKS cluster and pulled some graphs to be able to show what's going on here. So you can see that the first couple of workloads are running quite happily. This section wasn't sped up, by the way. Me pushing that and that being available and running is real time. This is sped up though, because I was getting bored. And so what you can see now is that some interesting and odd things happening at the same time. All of my nodes are up and are ready to be able to get load. Good to go. What you'll see here is you'll see that the CPU utilization has gone up, but my memory's gone down. And the reason is that it's looking for the used memory of the cluster. And what happened, I had no nodes, and so the memory consumption was actually quite high, but I had many more nodes, and so now it's calculating the memory consumption to be slightly different. So I'm just changing the graphics to be able to show different views of this, so it's a little bit easier to be able to see. And at this point, I basically spin this up, so you can see that actually on the top left-hand side is the number of jobs in the queue itself. You can see that's going down. And you can see the memory and CPU utilization going up now as well. The thing which was annoying about this, oh, and by the way, bottom left-hand corner, you can see that we're pulling around about 1 gigabyte a second from blob storage as well into the cluster to be able to do this analysis. The thing that's annoying about this is that actually the CPU and the memory utilization is pathetic. It's like, I should be bin packing here. I should be at kind of like 80-90% consumption because I'm wasting resources. And so the question is, how do we fix that? I wish I'd dial this down. I'm just going to zoom this forward a little bit. Let's see it completes. Here we go, right. So I want to fix this problem. The developer swore blind that he needed to be able to have a full CPU and 250 megabytes of memory to be able to run this workload, and I trusted him, or her. But actually what I'm going to do is use vertical pod autoscaler to be able to see what should the resources actually be. How can I bin pack even further into the resources I have? Because I only have 50 nodes to be able to run on this. So how do I actually fix this? Well, I'm running vertical pod autoscaling now to be able to just change the CPU allocation. It will check to see how much CPU is my application running, and it will modify that. And so what's happening now is that it's recommended my CPU shouldn't be a full CPU, it should be 410 millicores. And so I can go in now, and as you can see, I've got 3 of these analyzed workloads running on a single node. I can definitely stick another one in there to be able to better utilize this. And so I can take that now, go back to the engineer and say, hey, we need to change this because you've told me it's a full core, but actually it's only consuming just under a half. So what I now do, I can go and I can do the modification. You can, which is in this demo, set it up so that it automatically changes the allocation on the fly, so it will basically reschedule those workloads. It's up to you what you want to do, but I would highly recommend not running VPA in automatic mode in production, because things will go wrong and you will get paged at 2 o'clock in the morning. But yeah, VPA is really, really cool in terms of, especially in the scenario I was talking about, right? I know that I only have the budget for 50 nodes to be able to run this HPC workload. I can't go any more, or it could be bound by IP addresses. Developers are wonderful. I work with them every day. But developers and ops sometimes kind of don't think in the same way or think about the same things. And so if you really want to make sure that you're actually getting the best out of your workloads and the best out of the infrastructure that you have, VPA is a really cool tool to be able to actually do this for you. And as I said, it's an add-on, so you don't need to worry about maintenance on that either. I think I've... wrong one. Okay. 5,000 nodes in an AKS cluster. This is one of those features which is just like, and it is. It's the ability to be able to run 5,000 nodes in an AKS cluster. Currently, the limit is 1,000, and so for you to be able to actually do this, you need to go through a couple of hoops to be able to actually get this up and running for yourself. You do need to raise a support request within the Azure portal to be able to say, can I get 5K node support, please? Because we have to do some changes from a quota perspective to be able to get that lit up for you. So raise that support issue. Clusters must be using the uptime SLA. If you go to the size of a cluster of 5,000 nodes, your control plane, your API server, is going to have to do a lot more. And so we need you to be on the uptime SLA. You need to use Azure CNI network plugin. Overlay CNI support is there. So you're going to 5,000 nodes. You're going to be using a lot of IP addresses. So Overlay CNI will help you in terms of dealing with that. Cluster egress must be managed NAT. The system node pool must be a 16-core VM. Why? Well, again, bigger cluster, bigger system components that need to be able to run that cluster for you as well. And your Kubernetes version must be over 123. And just so that you know that I'm not lying, we have a cluster of just under 5,000 nodes there as well. So it's very, very cool, and I do want to commend the work that people did to be able to get us to this point. Okay, so we've talked about applications, we've talked about infrastructure, we've talked about networking. Now let's talk about storage. So again, it's one of those kind of interesting things as a cloud provider. We provide the managed service of Kubernetes on top of the Azure infrastructure. But as we light up new features in the Azure infrastructure, they need to be given to you to be able to consume them. And one of the things that we do a lot of work on is storage. It's about pushing storage for customers. Traditionally, storage is just a hard disk somewhere. But what are the IOPS on that? What's the scale on that? Do you need to push the boundary even further for analytics workloads, or do you have latency concerns, for example? And all of those types of things really then come down to how do I run those stateful workloads within Kubernetes itself. So when we think about container storage in Azure, really we think of it in the same way that as if you spun up a storage account within Azure itself. So we have Azure Disk to be able to store your disks. We also then have Azure Files, so network attached file systems, Azure Blob, which I demoed earlier on, which is just literally go, read blob data, page data, and then bring it back to me through an API. And then finally, we have NetApp files as well. We also then have an ISV ecosystem around that. So we work with Portworx, Kasten, Twilio, NetApp, Rackware, and OnDot, and more to come as well in terms of being able to light up some of that cloud native storage that you have, and building that out to be able to make it applicable for you. When we then think about using native storage, when we say native storage, we're talking about Azure native storage with Kubernetes. We do all of the integration for you. The container storage team themselves work extremely hard to be able to make sure that things are lit up from the Azure side of things into Kubernetes. And so one of the things that you may have seen was the CSI drivers, CSI v2 driver, which is coming now for disk itself, allows you to be able to have some of the really nice features in terms of snapshotting and those types of things. And all of those things come out of the work that we do with the storage team. All of these things are available through CSI, both disk files and everything else, allowing you to be able to actually integrate those and make your life as simple as possible. Again, who wants to manage CSI drivers? Well, we do, so that you don't have to. When we think about the storage provisions that we have, we then have to think what type of workloads are each one applicable for. And so when we look at disks, well, it's for being able to store data on disks and be seen as a PVC. Azure Files, which is pre-built, so things like SMB file systems, NFS file systems as well. So think about an ETL process, for example, where data is being pulled from an FTP server, being put onto a shared storage Azure Files storage, and then will be pulled in for you to be able to do analytics workloads on there. Underpinning all of this, which again should come naturally, is you get all of the redundancy that you would get with all of these outside of Kubernetes. It just works. That's the whole reason why we try and make this as simple as possible for you. I'm conscious of time. One of the things, again, I come from a financial services background and a high-performance compute background. One of the things which kind of, and I shouldn't get excited about this, but I do, I get excited by IOPS. I get excited by how fast you can push this and how low latency you can get some of this storage. And so when we think about the different storage options and the workloads that you may be running, if you just want to have a run-of-the-mill disk or pre-production and you want to save costs, then you'll probably go with a standard hard disk drive. If you want a little bit more oomph, you can go with an NSSD. But then it starts to get a little bit scary in terms of the IOPS numbers, because then you go into premium SSD, which is 20,000 IOPS, which can burst up to 30,000. Premium SSD V2, 80,000 IOPS. And then Ultra Disk, 160,000 IOPS. So these are crazy numbers in terms of how fast you can get all of this data in and out of those disks. But again, you just attach it with a CSI driver into AKS, and you can consume that in your workloads. The disk CSI v2 driver, I kind of talked about the snapshotting and the resizing that you get from this as well. And we will get more and more features which will be lit up from the storage team itself. It's currently available for premium SSD, standard SSD, and ultra SSD disk. And allows you then to be able to just manage that as a Kubernetes paradigm rather than having to deal with the infrastructure and the storage itself. With Azure Files, again, exactly as you would imagine, it allows you to be able to have integration with Azure Files, load up that Azure Files as a system volume into your Kubernetes workloads, and away you go. Again, you can go and create these file shares and these disks yourself if you want to, or we can dynamically allocate those for you as well, giving you full control in terms of, hey, I just need a bit of scratch space, just deploy that for me. Or if you have something that you're managing yourself, or you have a storage team, they can manage it and then bring that storage into AKS if you want to as well. And Azure Blobs, so again, for kind of analytics workloads, unstructured data type workloads, and really when you're thinking about things from a page perspective, Azure Blobs is perfect to be able to do this. Also is super cheap in terms of being able to actually store data and archive data if you want to be able to do that as well. You get all of those features which come through into AKS naturally. Azure Blobs is also interesting as well, is that you can obviously load it as a file system, a blob file system itself. Again, lots of different ways of you being able to cut and shove different storage, but you have full control over this in terms of how you want to be able to manage it. We can be, opinionated is the wrong word, we can help you as much as possible, but if you don't want our help, we'll let you get on with it yourself. So for the latest on container storage, so premium SSD is supported, improved disk attach and detach. So if you've ever attached a disk or detached a disk from an AKS cluster, you may see that it sometimes takes a bit of time. So we're definitely working on that and getting that a lot better now in terms of how we do that. CSI v2 is in preview. You can scale up disk volumes without downtime now. So if you wanted to resize those volumes, you can do that. And that's all there. Credit-based and on-demand bursting for disk volumes as well. We kind of have something similar in the compute realm in terms of having kind of credits which you earn over time for you to be able to burst out of for a specific period of time. If you went to 100% max, then those credits would be depleted, and then you would eventually accrue them back up again. So much like the B series, for example, B series compute. From a shared file system perspective, NFS version 4 on premium files and NFS version 3 on Azure Blob as well. This is really cool, right? Most of the workloads that you have probably going to be running on Linux, and Linux is really good at NFS, well, depending on how you configure it, but you get that support with Azure Files out of the box for you to be able to utilize those as well. I think Spencer said it this morning, your feedback really is important to us because that's going to inform what we're going to be doing the next time that we do this. So I really would ask people to just, good, the bad, the ugly, just scan the QR code and just give us your feedback because it really is super useful. So thank you very much. Are there any questions, by the way? Yes?
So there was a lot of upgrades. And you were talking about a lot of
Wait. I'm just going to warn everyone, the one and only half marathon I did, I threw up at the end, so.
Oh, thank you for this. There were a lot of upgrades about the node upgrades and other things we were talking about, but side note on the question, on the AKS upgrades itself. So, I mean, as a Microsoft product manager from your side, what do you suggest? Is it an in-place upgrade is better, or just spin up a net new cluster or migrate your workloads to the new cluster? Because there was a lot of complexities around which we wanted to, I mean, what we are doing, following it now is spinning up a net new cluster and migrating workloads completely. Yep. With the ecosystem pointing it out, there are a lot of other issues which we're facing out. So, but as a suggestion from the,
So I think George has an opinion about this. This is why he's walking towards me. No? Okay. So it is a trick question, and I'm trying to figure out the best way of being able to answer it. And it's not a get-out clause either when I say this. It really depends on your application. I've talked to lots of customers who are just like, you know what, the safest thing for me, I'm going to spin up a new cluster. It's basically going to be live, and then the switch over. Safest, right? We all agree that is the safest way to be able to do it, unless something happens with the switchover. In an ideal world, I would say in place, for sure. And the thing which is going to give you more chance that it's going to work is that if you have kind of 12-factor applications, right? Or because you kind of have to, otherwise you have to coordinate so many different moving parts to be able to do an in-place upgrade. This is the reason why we have things like max surge, right? Is that if you want to do in place, well, you could say, and pod disruption budgets, you can say how many of your nodes you want to be taken out. An in-place upgrade is going to impact your workload. And the reason why I say 12-factor is really about the health. So how does your application know that it comes back? And is the application just going to go, I've just died, and I've come up on another node, and I don't know what I'm doing, and everything goes to hell. And so that's why I say it comes down to your applications. I would always kind of say, you know what, node image updates and in-place updates are the way to go, but they may not be applicable to your workloads.
Thank you. Thanks.
So my question is regarding the managed Prometheus and Grafana aspect. One thing which I've kind of experienced with any of the managed services in Kubernetes is customer can or anybody can always go to the node and change the configurations directly, right? So how do you manage, or what's the direction which Microsoft has taken to kind of handle that situation? Like when it's a managed Prometheus setup, and somebody goes and directly fiddles with the configuration without going through the actual route?
So for both of those, they're completely managed, right? We don't expose, so it's not like AKS where we have nodes sitting within your tenant or your subscription. Those are much like app service. You don't see the compute infrastructure. So you can't mess around with that, and you can't tinker with the configuration files because it's completely, essentially hidden away and managed for you in that respect. AKS is a different thing altogether in terms of you shouldn't mess around with the nodes. You can. We really would like you not to, though. And that's one of the first things we'd look at as well in terms of support queries. But yeah. Pardon? Oh, yes. So yeah, from an add-on perspective as well, if you went and kind of tried to mess around with those, we would reconcile those. So even though the add-on is there and is managed for you, we do also go around and make sure it's like that add-on doesn't seem to be working or something weird has changed with it, and we will fix that, much like the kind of node reconciler that we use as well to be able to try and fix your nodes. We go and try and actively fix issues as we see them based on configuration changes and configuration drift, which may be down to the user. Question?
Yeah, thank you for the it's an amazing presentation. Regarding the storage performance for the system pools, you know that the HCD running there, right? So, and it's very like storage I/O, performance sensitive. So. The question is, the system pool nodes, are they reconfigured with the correct storage performance disks, or do we have to look into that?
Okay, so for things like etcd, that sits in our control plane, and we manage that for you, and so we make sure that that's running. Specifically for the components that sit within your system node pool itself, we have sensible defaults in terms of what the system node pool is out of the box, but you can also change that as well. So you could go, I don't know, you could go for an F series rather than a D series, for example, for your system node pool. We try to be as sensible as possible, but there will be situations where you may need to tweak or change what runs the configuration of your system node pool based on those types of metrics. And Patrick showed it as well. You can see the types of metrics that are emitted by a virtual machine, like IOQ depth, memory utilization, CPU utilization, where you can basically kind of tweak and change that if you want to vertically scale those, or if you want to have higher IOPS to be able to do that. George, comment?
Unnecessary turnoff. Yes, just a compliment on that also because I was boring in the sidelines. A comment on default specifically for system node pools. We, for example, will try to default to ephemeral OS, which gives you the I/O that you're talking about. Now, that is not going to be useful for etcd because, as Justin mentioned, that's not running on system pools. That's running on our managed control plane. And those already have all the necessary optimizations from our side, not just on I/O, bandwidth, right sizing, backups, all the things that we do there. On the system pools, you still have the flexibility to manage it. Our defaults are, I would say, pretty good, but we're always improving. And I would say the problem with defaults is that the devil is in the defaults, and that is really a case where you want to make sure that you have a minimum size for it, that you have a minimum number of nodes, like you have multiple core DNS replicas, you have multiple of these system components, you have multiple tunnel replicas. So you don't want these running on the same node. Oh, Kubernetes, you have resources and limits, so Kubernetes does that. Yeah, for CPU, for memory. What about for I/O? What about for bandwidth? What about for all the things that are not necessarily controlled by those kernel namespaces that actually are protecting you there? So it's important to ensure that you have a right number. The defaults are going to be typically trying to save you. So if you select something like a D8 VM, D8S VM, that's typically a VM type that we see a lot for system. And then you have like 3 or 4 just for high availability and ensuring that core DNS can, for example, scale to 5 replicas or more and spread them across. So all these things. So depending on the size that you're going for, it's really important to have this kind of foresight and make sure, for example, the system pool is auto-scaled and has this, maybe you start at 2 nodes, 2D8 nodes, perfectly fine, small cluster. You let it auto-scale. The system components will always try to schedule there, and you can leverage that pool more efficiently, more effectively.